I want you to go ahead and try out the first one. Take a couple of minutes for this. Let's start then. The first question. All right. I hope you've been able to give it some thought. Let's begin with the discussion for this. Now, the number one trap that you find in data sufficiency is typically the assumption trap, right? Where you assume that a particular number has to be an integer, and that's where usually people go wrong. Now, when you look at the first statement here, it says n is divisible by the square of a prime number y. Now, we don't know what is the prime number, and that gives us no information about n. We don't know how does y relate with n, at least not with the second statement individually and independently of the first one. So both of these statements individually at least are not sufficient. And once you've been able to knock both these statements out, you realize that the answer is either going to be C or it's going to be E. So now you have a 50% chance of getting this question right. Now, if you're saying that if it's saying that the prime number y, so y we know is a prime number. So if y is a prime number, then we know it has to be an integer. And if you're given that y to the power 4 is a 2-digit odd integer, then the only integer value that is going to suffice here is 3. Because if you take y equals 3, then y to the power 4 comes out to be 81, which satisfies the second statement. So we're talking about combination here, right? So both the statements have to be simultaneously satisfied. So from the first statement, we know that y is a prime number. If it's a prime number, you're only supposed to look at positive integers. Second, since you're given y to the power 4 is a 2-digit positive odd integer, then you can only have y to be 3. It can't be any other value. So now you get to understand that since n is divisible by y square, and what that means is when you divide n by y square, the remainder must come out to be 0. That means n is divisible by 3 square. That is 9. Now, if n is divisible by 9, that means that n could be 9, n could be 18, n could be 27, 36, 54, 81, so on and so forth. And one thing you'd realize is that although it seems like you're getting so many different answers, but understand the question isn't concerned about the value of n. The question is concerned about sum of the digits of the positive integer n. If it's concerned about the sum, then look at the sum here. Here the sum is 9, here the sum is 9, here the sum is 9, 2 plus 7 is 9, 3 plus 6 is 9, 4 plus 5 is 9, 5 plus 4 is 9. This is a property of numbers that are divisible by 9. Numbers that are divisible by 9 have the sum as 9. Now things would have been very different had the word prime number not been given to you in the first statement, right? Things would have been very different and it would have been a really good question, definitely a much better question than what we have right now if the word prime number weren't given to you. And I'll let you think over it on your own as to how is that going to impact the answer, but it would have been a much better question than what we have here right now. So for the first statement, the combination is getting us the confirmed answer. It is getting us a unique value for the sum, and it comes out to be 9 in each case, right? So for the first question, the answer is C. The second one that we did, the answer was A.